All right. Looks like it's time for day 9. We are making our way. You know, I thought this was our little island, but what was yesterday saying? Your flight to the major airline hub. Is that? What is this? Mini airport? It looks like we're in the water. You land at the regional airport just in time for your next flight. I mean, we did save Christmas multiple times. You think we could get a direct flight. Flight approaches the regional airport. Day 5. Yeah, day 4 was the regional airport. And then what is this? They're just showing us we're turning? No, you land at the regional airport. It's confusing. But, oh well. So yesterday was pretty rough. I didn't read a key piece of it, and it definitely caused me a lot of time trying to figure out the second part of the solution. So ideally, on our next one, we should be reading the quiz. Should we have this gap right here? What's going on here? We did have that opcode thing where we're having a little like toy processor. I remember seeing this in the 2018 one. It wasn't this one exactly, but it was something similar. And I remember that one did span multiple days, so we may see another instance of this, jump, accumulate. We may see other opcodes. Yeah, this is one of those things that's kind of like very prone to off by 1 errors. Gotta be pretty careful with it. Parsing wasn't too bad. Let me get my text file added. What do we do for parsing? We had a tuple list. And then we had a hash set of our run codes. Not too bad. All right. Here we go for day 9. I think the goal for this one is to understand the problem correctly and not spin our wheels too much. All right, day 9. We are on the plane, enjoying the video game. The data appears to be... You managed to connect it to your computer. We're trying to hack our entertainment system here on the plane. It's encrypted. Xmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediate previous numbers. So it sounds like we have like a Caesar cipher kind of thing going on. The 2 numbers will have different values, and there might be any one from any pair. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of 2 of these numbers. 26 would be a valid number, as it is, could be 1 plus 25. 49 would be valid. 100 would not. 500 would not. Suppose the 26 number is 45, and the first number no longer an option as it is more than 25 numbers ago. So it's always the last 25 numbers. That's your preamble, I suppose. Let's see. 26 number is 45, and the first number was 20. Now, for the next number to be valid, there needs to be the same pair of numbers among 1 through 19, 21 through 25, or 45 that add up to it. One through 19. How do we invalidate a number? Transmits preamble of 25 numbers. After that, each number you receive should be the sum of 2 of the 25 immediate previous numbers. The two numbers will have different values, and there might not be more than one such pair. There might be more than one such pair. Okay. It's just saying the numbers in the index 1 through 25 or 26 instead of 0 through 25. Let's see. Here's a larger example. It only consists of the previous 5 numbers. It has a preamble of length 5. In this example, after the 5-number preamble, almost every other number is the sum of 2 of the previous 5 numbers. The first step, the only number that does not follow that rule is 127. The first step of attacking the weakness in the XMS data is to find the first number in the list, which is not the sum of the 25 numbers before it. Okay, so let's start with the practice data. So we have what, list of integers. I guess it can be an array. Why not? Let's see, read lines, select, turn this into parse these. You know what, let's change this to long, just in case. All right, parsing done. So we want to say we'll have a function here called contains sums. Our first parameter will be the sum that we want to evaluate. And let's say the index that we want to start from. Let's see, so we'll return what do we want? I want to take a splice of this, which is not easy to do in C#, unfortunately. How do I get a subrange? Number of elements. Is count already? Is that a dynamic number? I don't know. Let's see. Contains something that contains any two numbers. I need to search through this twice to find the sum. This seems kind of dumb. So if nums first check plus nums second check equals index, no, sum. We get here, we're going to return false. Let's see. Contains sum of d. Oh, I need the index, don't I? No, the sum, which is, I guess we don't need this index thing here, because it's just going to be or the sum thing, because we could just grab it out of the numbers. What are we looking for? 127? We probably have an off by one error here. Yeah, we got what, 35? We do need to restrict this to the last 5. Well, we need to start at 5 and then restrict this to the last 5. So index 5, because we want the last 5. And this, we need to restrict this we need to start 5 to the 5 below the index. Right? No, apparently not. So the first number we should be checking is 40. right? So we're at index I, which is, or index 5, which is 40. And we're going to check, we should be checking I0, J0. Oh, wait. We can't be checking the same number. Still not getting a correct value. Why are you returning true? Hotkeys. Okay, you're returning true because we're at 2. Oh wait, we need to check if it doesn't contain the sum. And we get 127. Okay. All right, so let's try this with our puzzle input. And the thing that we need to change, ooh, let me paste that again. Okay. The thing we need to check is whether instead of 5, we need to do 25. Correct? Starts by a preamble of 25 numbers. And this was a preamble of 5 numbers. Okay. So we got this guy. Are you the correct answer? Yep. All right, looking good. The final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. Consider the above example. In this list, adding up all of the numbers from 15 through 40 produces invalid number from step 1, 27. Of course, a contiguous set of numbers in your actual list might be much longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, there are 15 through 47, producing 62. All right, so let's do this again. So let's use a preamble number here instead of hard coding in these numbers. Because we're going to go back to this and use the test input one more time. And what we're going to do, what we're going to do is find our invalid number first. All right, and then we're going to find that contiguous set of numbers. So we're going to start at 0 this time. And we're going to have to search through, each time we go through, we're going to have to create this new search of all of them. No, we want to start at I for J. Should it be at I? No, it should be at I plus 1? No. J is fine. Yeah, J is fine. So we're going to add to our working count. Let's see. If our working sum equals our working sum equals our invalid number, we have found our solution. Working number is greater than invalid. We have not found our solution, and we need to break out of this loop. Now, if we've gotten down here and we've found the solution, then we want to return the sum of the smallest and largest number in this contiguous range. So that would be I plus J, which would be our starting and stopping number. Let's see. We're going to set found to our J variable. Now, we also need to break here. And this guy needs to be found. What did we do? We needed to close out that loop. Nope. You need to be in the loop. There we go. 55. Is that the correct answer for this guy? 15 and 47. No, it is not. So what did you find that you thought was correct? 2 through 5. Which is 15. 0, 1, 2, 3, 4, 5. 15 and 40. So you should have added You should have added 15 and you should have added 40. Add together the smallest and largest number. Geez. We can do the get range for once. So we'll start at I, and it'll be I plus found. Might not be right. No, it should be found minus I, which would be a count of 3. Plus 1. Min This is our contiguous set. And then we want to return min plus max. $62. Are you right? 62. Okay, looking good. Let's try it with our text. We need to change our preamble to 25. Run this. Now, were there any secret rules I forgot about? Nope, apparently not. We got that one. Ooh, not too bad. For me. Let's see. Well, yeah, not... Apparently, this wasn't too hard for other people as well. Well, that's fine. At least this one didn't take me an hour. Yeah, if you're here for a elegant, fast solution, this isn't where it's gonna happen. What's going on with the weird spacing here? I guess it's needed to showcase the extreme distances we're traveling for our vacation. Yeah, that one wasn't so bad. Not a great solution. There's probably a much better way to cut down the time that we're searching through this. But at least we are, I guess when we do our contain sum, at least we're checking only the, set of numbers we need to. Wonder if there is a faster way to accomplish this. Yeah, who knows? All right, well, that's it for this one. Wasn't too bad. It was mostly just, we're searching through a list of numbers. Kind of the trick here is more, making sure we're searching the correct, sub-array of our main array. Making sure that we have the proper logic in here, such as, not checking the same number against itself when we're trying to figure out sums. Yeah, besides that, not too bad. All right, that was day 9.